Okay, this is a build video for, well, I've been showing so many classic paddle foot robots. It's the kind where the feet move. I thought I'd do a 3D printed version of my own, but I'd also add some sequential, or actually random type lights and an electronic sound effect, and run the whole thing off a single battery and put the files up on Thingiverse. Any of you that want to make one can, but basically you can see it's going to walk with the standard paddle foot walking. I've got a sound sample that's kind of mechanical. And we got the nice lighting effect in the chest. So after I built this first one, I thought I'd do a second one and add a few more things. I was going to add a separate place for the speaker sound to come out. This one is kind of enclosed in the body. And I thought maybe I'd add some chest detail to fill this blank void up here a little bit. I think that's about all we need to know to start. Basically, the first thing you're going to print would be the body, and it actually prints as you're seeing it stand here. And the only place that I put supports, I go supports on the build plate only. It actually runs a thin layer of supports up to a cross member inside the body down in there to support that. And it adds some supports right here on either side for this overhang. And I think, yeah, I'm pretty sure it ran supports up through this battery box, although they're not really required there. The really only place you're going to need them are going to be here, here, and one that goes up and hits this cross brace right here. That cross brace is for holding the motor in place, holding it together. I'm getting a motor so I can show you what I'm talking about. Using the TT gear motor, the 1:48 gear ratio. See how it's got this plastic strap across the top? That holds the motor down into the gearbox. We'll actually take that strap off. So once this is pushed up inside the body, there is a cross member that the motor gets against, and that's what holds it in place. But I didn't have room to accommodate the strap without changing a lot of the geometry of the toy, which I didn't want to do. Okay. Now, as far as getting yours prepped to the same point that you see this one, see, basically the motor just pushes in from the bottom. Well, I pulled the motor out of the gearbox. That's not ideal. But I wasn't actually planning on taking this whole thing apart. So here you can see I've got the there's the camera. Got the two wires connected to the motor. The motor itself just goes right down into there. Let's see if I have it all the way down in. Yep, it's running. I run the two contacts on the motor on this side. Now, as you're looking at it, that's your right side of the screen, but that would be if you were looking at it from the robot's point of view. That's the robot's left side. So then the motor will just push up in there, and you'll just go all the way up. The bottom will be flush when you're all the way there. Okay, now we're going to put some wheels on there. These print on the printer flat like that, no supports, and I've painted these black only because I wanted them to look black. I got a couple rubber O-rings from my Harbor Freight O-ring kit that just snap on there to give it some traction, like so. And you can see they're got the D-shaped, so they can only fit on one way, and that's important because you want, there's a key little offset hole that we're going to be going to. You want the wheel that you put on the other side to be the opposite, so in other words the hole to be here, so that you can get the cool paddle foot movement. There we go. So they both push on. Now, hold them on, I take a couple of very small number 2 screws, self-tapping, and just screw them right in like so. Now, there's a lot of different ways you could build this. You can build it with sound, you can build it with lights, or you can just build it with just the motor movement. And since I haven't got another sound module right now, I'm not going to be describing that. if you're going to build it with just the motor movement, you take your battery holder, you just glue it in back there, run the 2 wires up, take one of the battery wires, in my case I took the red one, solder it to one side of your switch. This is the standard switch I use, it's 19 millimeters on mounting holes. And then get another wire to run from the switch to extend, maybe keep it red so you can keep everything straight in your head. So then you have your black wire and your red wire that you can turn the power on and off with and just bring them down and solder them onto that motor. Tuck the wires down through, solder them out here, then jam it all up in there. Now in my case, I'm running those flashing LEDs. The flashing circuits are actually in the LEDs, and to run them though, you need higher voltage. You don't need more current. Actually, I only need 5, 6, maybe 8 milliamps to do what I want to do. So I get little inverter booster boards. You can find them just all over the place, and they're all different sizes. This is actually one of the larger size physically, and just because it used to have a USB port on this end here, which I removed. And I soldered in a 330 ohm current limiting resistor for the LEDs right there, because it had all that real estate that wasn't being used. Well, the 2 input wires to this, just bridge them right across the motor. Just make sure you get the positive to the positive and the negative to the negative. You'll be good to go. And then when I get ready to hook up my LEDs, I'll be hooking my ground here and my positive after it goes through that 330 ohm resistor to limit the current. Because you don't need to hit the LEDs with a whole lot of current. They're plenty visible without going that carried away. Okay, the next thing we're going to put on are going to be the arms. There's a left and a right arm, and they print flat on your bed like that. Again, don't need any supports. There is an opening in the back, and then there's this arm peg part. And what we're going to do is push this in from the inside of the body, put some glue down in that hole, and then jam it in and glue it, and then the arms can freely move. So, like so. I'm going to go in there, and there it is sticking out. And make sure you get the right arm, because you don't want to glue the wrong arm on. Just go ahead and put some glue down inside there. There we go. Didn't want to come out. That's what she said. Alright, get that on there. As you can see, I already did some painting to the arms, detailed the claws, that. A little black there, little detail painting there. Let's get the other arm on exactly the same way. Push the post in from the inside. Some glue down in there. And if you do it right, they should be able to move. If you get sloppy with the glue, it ain't gonna move, is it? Okay, how about the paddle feet? Let's get the paddle feet. Got them back here. So, as you can see, they print, they're both identical. They print flat on the bed like that, no supports. And I've already gone and spray painted these with a dull aluminum. I thought that would look good for the feet. And what I have here is some 256. They're a number 2 screw and 56 threads per inch. It's a machine screw that I'm using, and if you were going to measure them in millimeters, it'd be about 10, 20, 24 millimeters long, thereabouts. If you're, oops, and of course it has disappeared. Got a wide open floor. So this build is not going to be going well unless I can find that screw. God, it only bounced twice. Well, ding, 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 ding. 3 times maybe. No idea where it went. So I won't be able to put one of the paddle feet on. These particular screws, I mean, I guess a guy could use nails or something too and just glue them in. These particular screws have a common, I'm trying to look for a common screwdriver. Why didn't he already have all that stuff out? I didn't feel like thinking ahead. I've been thinking too much recently. Time to stop thinking. So I'm going to take the screw, I'm going to poke it through this side. This nubbin side's going to go up against the wheel. Like I say, the wheel had a hole in it, if you remember right. I told you we wanted to make sure we got the holes in the wheels opposite each other so we can get a nice paddle foot looking action going. And it should self-thread and tap right in. I'm sure there's some sort of metric equivalent. I think the number 2 sizes are pretty close when they get that small. I'm making sure it's loose on there. I don't want it to be binding at all. Easiest way to do this if you're using a screw is to go ahead and put it in there and tighten it down to where it's snug and then loosen it up at least a half a turn. So basically what you have is that. Now we're going to try to go through this slot and hit this hole in the back. Easier said than done, right? I think I got it. Like so. And again, you don't need this one tight at all. In fact, it's better if you leave things a little bit on the loose side so that everything can give and move. You don't want anything binding, so let's turn it on and make sure it gives and moves. Not bad. One thing I didn't mention is on the very bottom here there was a hole, and I already put a screw head in there. That's a drag in the back because you have the 2 wheels. This allows you to adjust the height of the rear of the robot, and it gives it something to drag on. It was a common way on these paddle foot robots to do things. Some of them had wheels back there, but usually the wheels were so cheap they didn't turn. A lot of them just had divots in the metal to work as a center drag point. This case, I'm using a 632 screw here in America. It means it's number 6 in size, 32 threads per inch. Since we haven't found the screw that we lost, I will put the one on the wheel, and we're just going to have to live without the one in the rear for the time being, because I don't know where it went. You know how that goes. You drop a screw on the floor, you should be able to see it, you listened, you're going, well, it only bounced, you know, maybe 2-3 times, and they were in fairly quick succession to each other. How far could it have gone? You'd be surprised. Okay, now we're to the chest piece part. I printed mine in a translucent red only because the LEDs, which I have already put on the back side here, were red, and I wanted them to light up really well. If I'd had some green flashing LEDs, I probably would have printed this in translucent green because it would look better on the body. Then went ahead and pre-painted the chrome rim around the red part to give it just a little bit more detail once it's snapped into the body. And as far as the wiring goes, I have 3 flashers, you know, they're all in parallel with each other. Just keep track of which leads positive and which leads negative. And then I did throw a capacitor across there. We got that 330 ohm resistor feeding the 5 volts to this to current limit everything. But this helps clean up any noise from the motor so that the flashing LEDs will work better. It could actually be any value capacitor. It could even be a 0.1. It's not important what it is. It's just important to have something on there to help clean the supply out. Now this is going to snap in from the inside, and so that you don't get a bunch of messy glue marks on the outside when I snap it in from the inside, then I just go ahead and apply glue to where it meets the body from the inside, so it won't push out, won't go anywhere, if you know what I mean. I probably won't be gluing it in right now during this build, because once I do get a sound chip, I have more ordered, basically a greeting card chip, and you can get them in 10, 20, 30, 60 second. You can get them in 120, which is 2 minutes, and you can get them in 4-minute lengths. Just about any length of time you want for your sample. Okay, so this is going to poke in from the inside. If I can get these wires out of my way. Like so. And there. There it is, poked in place. And like I say, I would glue it from the inside. If all you had was hot melt glue, fine. Go ahead and lay some hot melt glue on the inside so that that won't fall out. In the end, these two wires are going to simply solder to this inverter board that we briefly talked about earlier, and that's going to get all the lights blinking and flashing and carrying on. Let's see, what do we got more? We got the head. Okay, we're almost done. There's not very many parts to this build. And I'm picking up the head parts right now. So, there's two head shells, there's a left and right side. I print them in this way, no supports required. This can be cut out. It's made super thin on purpose. You could run an X-Acto knife and cut that out in case you wanted to have a light in there that would illuminate the ears. So in this case, I did do the ears in a translucent green. I'm not putting any lights in the head. I'm just saying you can, it's an option. On this one, I did them in a translucent red because I thought the red looked better with the blue. This case we'll do it with these. Then there's the eye, and it prints flat. As you can see, it has a ridge, which means it gets inserted from the inside, glued in place. And that's what it's going to look like when you glue one of the ears on and glue one of the eyes on. Then if you do all of that, you will then glue the two head halves together. The two head halves, there's a little neck ring there, can then glue to the shoulder piece, so that'll align everything. And as you would expect, just drop the head, the shoulder piece can glue on top of the body. You're done with your build. I don't want to go much further with this build until I get the sound chip. So that's why I'm just kind of describing to you how it's going to go, not necessarily that I've done it. But as soon as I get that one done, I'll shoot a video demoing both the robots, the blue one and the new red-orange one. And I'll probably release the video of them both done, demo working first, and then release the build video you're watching right now. And that way, that'll give me some time to get the files uploaded to printables and Thingiverse. It's an easy build, it's a simple build, you don't have to do any of the electronics. You can just wire the battery right to the motor and have a cool walking robot. Or you can go ahead and add the electronics. You can add more, you can add lights up into the head and the ears. You could, you don't have to do the sound chip, but the sound chip is fun because you can make it say or do absolutely anything you want. And a good place to get sound files for loading on one of those greeting card chips is right on YouTube. Just type in whatever type of thing you're looking for. I'm looking for factory sounds. I'm looking for robot sounds. I'm looking for whatever it is you're looking for. And you'll find that there are effects sound files, and you can just play them. And most of these little greeting card chip things that like I used in here, normally they have like 3 button cell batteries on them. You're going to remove the 3 button cell batteries and connect them right up to this same voltage booster that we got, because they'll run on 5 volts just fine, and that gives them its power. And then many of them, there's a button that you normally have to push to make them play. Well, if you solder the play button closed, in other words, if it was being pushed all the time, as soon as power is applied, it'll automatically go into play mode on many of them, on all the ones that I've used anyway. So that's what I've done here. I've grabbed sound files off Thingiverse for this guy, because I really liked the clanking. It just seemed to fit what I envisioned with a computer type mechanized robot. Now of course, just like I've done on my other robots, you don't have to go with just an on-off switch. You could go with a 3-position one switch where the center is off, and left could be forward and right could be reverse, just by flipping the polarity of the battery through the double pole, double throw, center off toggle switch. But because it'll fit in there. I didn't really need reverse on this. I was thinking forward, and the sound and the lights were going to be cool enough for this build. So hopefully I'll get my parts together, I'll get the demo up, and then we'll get this build video up and see if some of you guys can do a build on this.